So today we want to quickly talk about these two. May I ask if this, if that my mask?
I have to do one.
Okay. If you guys are not going to be freaking out. Is anyone familiar with the idea of other neighbor functions? Anyone? Okay, but these two words, you know what it means, right? What do you remember about them?
Odd is 1, 3, 5, 7.
So you're related to numbers, odd numbers, even numbers, something like that. It's kind of like that in a function, based on what I'm going to explain very soon. I give you a function. Check this out. Let's look at functions with maybe even power. Just a monomial function, like this. F of x equals x squared. Alright? Let's see, on this side, let's look at function with even power. Let's look at, that's too much.
And we actually,
Yeah, this is what I need. This is cube, that's odd, right? Pick two numbers. Think of the positive and the negative of such number. Substitute them differently in those two functions. Tell me what you observe. For example, if I pick a, then I also pick minus a. See what happens when you substitute here. See what happens when you substitute here. Can we do that quickly? Pick a number, sorry, and the opposites, so make it 2. Like making, let's say for example, I pick 5, then I also pick minus 5. Test both 5 and minus 5 in both functions. I think we can actually do that without spending more time. What happens when you substitute both the negative and positive in here? You get the same. But what happens when you substitute in here? Not the same, right? Okay, so let's see. So basically, if you put f minus 2, you get that. If you put f of 2, you get that. This is 4 and this is 4. So you get, is it true?
yes.
Is that not? So let's check this. F minus 3, negative 3 cubed, yes? Negative 27, right? F 3 is just 3 cubed, which is 27. Yes?
Yes.
So how can we do the same conclusion? This conclusion, what would it be here? Karen, right. This same conclusion, give me something for this one. After this calculation, we came up with this. Now, we have done the calculation here, give me a similar conclusion. Ah. No, say that again. Uh-huh. This is the simple definition of what an even function. If a function is even, this is how I remember learning, growing up. I remember x squared because the power is even. Then if I forget in an exam, I check with the positive and negative number. I realize that, oh, they are the same. So the definition of an even function is that f of x must be the same as f of negative x. But in the case of odd function, f of x must be negation, f of negative x must be negation of f of x. It's like the minus is out. But here, the minus is absorbed. Do you get that? The minus is absorbed within it. But here, the minus escaped eventually. Then this is an odd function. Let's check some trig functions. Take your calculator. Check sine, cos, and tangent. take different values like this. Tell me which one is odd function, which one is even function. And maybe if you have anyone that is neither. What I'm saying is, take your g of x to be sine x, or g of x to be cos x. Then check tan x also. Check if they are odd and even. I ask you to do something. You're just sitting down like you're not one of those I'm talking to. Yes?
Sine is that one.
Sine is what?
That one.
Speak again. It's louder.
That one.
What is that one?
G of x.
It has a name.
G of x.
What function? Leo.
Cos x.
What?
I don't know what they want.
You want to try?
Sine is an odd.
Sine is an odd function.
Oh.
What did I ask you to check? Check if it is odd or even, not that one. There's nothing like that one here. Sine is an odd function. Is that true? Okay, so let's check the others. Cosine is even. Tangent is odd. You know why tangent is odd? Tangent is what as a ratio? Say that again. Sine divided by cos. So you're having an odd function divided by an even function, which means you have no problem with the denominator, but the numerator still behaves abnormally. Do you get that? So we shouldn't be surprised that tangent is actually an odd function. Am I making sense? Okay. So this is the definition of sine and odd and even function. So let's write this briefly. Odd function. A function f of x is said to be an odd function if f of minus x equals f of x for all x. So this is the main condition. Graph of an odd function we will see as a rotational symmetry.
Mr. Daniel?
Yes.
Isn't one like the functions equal to each other like that is a leading
Oh,
function?
my bad. So there should be a minus. Yeah. Sorry. Thanks. Yeah. The minus is not absorbed. Rotational symmetry is about the origin. We all know what the graph of cubic function looks like, for example. Remember? Cubic function looks like this, isn't it? If this is x to the power 3, well, this would be your, so if you rotate, you know, remember rotational symmetry, right? You can only rotate once to come back to the original shape, which is after it rotates 360. Do you agree with me? So that's why we say it has a rotational symmetry, of course, about the origin. Just something, do you understand what I mean? Yeah. You know what rotational symmetry is? Like how many times do you have to move it clockwise, anti-clockwise? Nobody cares. Usually people just move clockwise to come back to the original shape. So for example, a rectangle has how many, it has rotational symmetry of how many order? 2. Because if you mark this point, the first one you have will be this, with this point being here. right? And the second one will be to come back to the original form. So there are 2 times to get that. Okay? If you have an isosceles triangle, what is the order of rotational symmetry? 1. Because you can only, after you must have rotated 360 degrees. But what about a square? 4. Okay? So when you have a cubic function like this, for example, you only have 1, just like this one. Okay? Because by the time you go up this way, wait a minute, is it 1 or 2? When this comes here, isn't that 2?
Yeah.
You have 2 in this case. If you move this shape, unfortunately I can't move this. If you move this shape about here, this part comes here, right? Then you have the same thing. Okay? So it may not be, did I say a rotational symmetry? So let's just say as rotational symmetry without talking about how many, what is the order. Okay? So that's an observation if the function is an odd function. For even function, let's write. Can we still do this or do I go to the next? Is this okay? Okay. Even function. So a function g of x is said to be an even function if the condition this time is f of negative x must be f of x for all x, of course, in the domain. Maybe we say for all x in the domain. The domain could be anything. In the case of trig, the domain will be the domain of the angles, right? So for all x in the domain of function. So again, this is what we need. Did I say f again instead of g? That should have been g, since we changed it. If g of negative x equals g of x. Thank you. So this is what we need to work today. What do we notice about an even function like this? That's f of x squared. Right? What do we notice about that? Symmetrical. Okay? Symmetrical. In this case, especially about the y-axis. Right? Symmetrical. So I wouldn't say y-axis. Yeah, I think so. Yeah, you can say about that. So because if this is x squared plus 1, what does this plus 1 does to this function? If I create another function, x squared plus 1, what does it do to this on the graph? Shift it to the top. Does it affect the symmetry? No. Okay. So here, it will be symmetrical along the y-axis. So basically, the y-axis sounds like a line of symmetry to it. Do you understand that? So let's, right? So, but most of the functions we are discussing here at the moment, they are actually algebraic functions. That's what we'll be working with. Algebraic functions, rational functions, polynomials, and things like that. So let's move faster. So the point we will write here, so maybe I use that, is that the graph is always symmetric about y-axis. So let's clean this up. we'll take some examples. Let's go straight to the exercise. Show that, so if you have your book, go to exercise 6A on page 153. Exercise 6A on page 153. Are you there yet? So let's take, which one should we start with? How about we do together question 1, then, or question 2? I'll go with 2. Because some of us might have a difficulty with odd functions. So let's do odd functions together, then you can use the same idea to be even functions. And the rest will just be practices. Practice. Alright? So, no. I believe this is the eraser. Yeah, it works. It works. Okay. So, let me tell this to go back in. So the first question, can you tell me question 2? Show that.
Show that f of x equals to x cubed.
Hold on, sir. Show that f of x equals
X
x cubed
cubed minus 3x
minus 3x
is an odd function.
is an odd function. Okay, so solution. Solution to that goes thus. Now, what is the condition for it to be odd? Don't forget, here, you start with the negative and you try to show that that minus can be extracted. You start with the negative, show that it can. So if the function is not labeled as f of something, you need to give it a name to be able to write properly. For example, if the question just says show that x cubed minus this is odd function, you start by saying let this function be f or g or whatever you want to call it. Have a label. Alright? So what we want to show is to show that f of negative x, so you start by doing f of negative x. And you conclude. Don't simplify f of negative x, simplify f of x and show that one is minus the other. Don't do that. Start with this one. Then substitute. What is f of negative x? Let's do that together. Negative x cubed
Minus 3x.
and simplifying this gives what? Negative x cubed, yes, plus. Your goal is to be able to factorize the minus such that everything that remains as the second factor is your original function. Is that possible here? Of course. When minus is factorized, what do we have left? X cubed.
Minus 3x.
And what is the content of this bracket? The original function. So which means negative f of x. So basically you started with this and you end up with this. And that's how you prove that it is an odd function. In the case of even, you start with this, you end up with no negative. Then you conclude. Therefore, f is an odd function. Questions? So I'd like you to start with question 1 in the textbook. I'll write it here. this is easy, right? This is very easy. Have you done it? It's possible for a function to be neither odd nor even. If you check, your f of x doesn't give you minus x, and it doesn't give you minus f, and it doesn't give you f itself, then it means it doesn't meet any of the criteria. So it's possible you have that. If you look at an example given on page 153, look at example 1b. No, 1c. That quadratic function doesn't satisfy odd property, neither does it satisfy even. That's why it is neither odd nor even. So it's possible you get that. Okay? So I want you to look at some problems from number 4. Determine whether it is either for odd or even or neither. So I'll write some of them out. Each of this is odd, even, or neither. So let's pick B, which is f of x equals negative 4x plus 3. Let's pick C, is a rational function. F of x equals 3 divided by x squared minus 4. Let's pick D. X cubed minus 5 over x. So I picked, now this is B. So I just call it maybe A, B, C, D here. And I pick question, which is question F here, as question D on the board, square root of x. Okay, yet? we done 2?
Oh, yeah.
Last one. Has we done 2A? Who's still here? No one? 2A? You haven't done 2A, so what exactly are you doing? You have not done A.
I done A.
Okay, so you've done A, B, you're in C now. Good, good. So we do this together. If you're not able to do it, but I need you to make an attempt first. I'm also going to write one about inverse function, which is the last question in the exercise. We'll also try that together. Some of the questions you will see in that activity has to do with trig functions. Some of the some of the identities you need to prove that we have not learned, which will be in our next topic, topic 3. So I'm going to skip those ones until we are ready. Okay? There are some questions on mathematical induction that is also trig based. We'll treat that when we learn some trig stuff next topic. Okay? So let's be fast. By the end of today, I don't want to talk about order naming anymore. It's as simple as that. Just using the property, trying to manipulate, using your algebra skills, and that's it. I'm going to give you an assignment to be submitted. Today is Tuesday, we are not meeting on Wednesday. Our next class is Thursday. I'd like it turned in maybe Thursday morning, so I can have a look before we come to class in the afternoon. Okay? So I'll give you some work. Maybe I put the question reference here. And you can, I'll send you the picture of the pages in the book later. You don't have to go home with your big textbook. Yes. Anyone struggling with any of the questions?
C.
C. Has anyone done C? Leo seems to be struggling with it. Have you done C? Is it odd, even, or neither? Speak louder, sir.
It should be an even function.
I didn't get that.
It should be an even function.
An even function. Do you everybody agree with that?
Wait. No. It's an odd function.
Odd function.
Okay, let's see, Mr. Leo. So again,